Hello everyone, I wanted to look at this particular question, integration question, because it's got some quite confusing ideas, especially towards the end of the question. And I know that students have often found the later parts of this question quite difficult. So let's have a look. It says figure 2 shows a sketch of part of the curve with the equation y equals x times by x add 2 times by x minus 4. The region R1 shown shaded in figure 2 is bound by the curve and the negative x-axis. Show that the exact area of R1 is equal to 20/3. Okay, so first of all, we can see that the equation that we're given is x add 2 times by x minus 4. So that means that the roots of this equation are x is equal, the solutions are x is equal to 0, x is equal to minus 2, and x is equal to 4. And we can see from our graph, let's just mark those on. So here's our cubic equation, and this one here is the minus 2, that is 0, and that is 4. So the significance of this is that in order to find our region R1, here we need to integrate in between minus 2 and 0. So let's do that. In order to do that, I think we should first of all expand the whole thing. So let's just do that. I'm going to expand first of all the quadratic. So that's going to give me x squared minus 4x plus 2x minus 8, which is going to be x times by x squared minus 2x minus 8. And then when I expand that, that's going to give me x cubed minus 2x squared minus 8x. Okay, so that's my cubic. So I'm going to integrate that cubic in between minus 2. This is question 8, and that's part A. I'm going to integrate this now between minus 2 and 0. So in order to find R1, x cubed minus 2x squared minus 8x dx. So that's going to go to raise the power by 1 divided by the new power, a quarter x to the 4th minus 2/3 x cubed minus 8 x squared over 2 in between 0 and minus 2. Okay, so that's what we're going to evaluate. Now, when we put 0 in here, we're going to have 0, 0, 0. Okay, because they've all got x in. And then when we put minus 2 in here, we're going to have minus 2 to the power of 4 divided by 4. Okay, so 2 to the power of 4 is going to be 16, and 16 divided by 4 is going to be 4. So the first term there is 4. The next term turns out to be minus 16/3. And the next term is minus 16. And when we add all that up, that comes to 20/3 as required. So the first bit there, really not too bad, pretty straightforward, kind of like a nice 4 marks. Okay, it's the next bits where this question, I think, becomes a bit more challenging. So it says the region R2 also shown shaded in figure 2, bound by the curve and the positive x-axis and the line with the equation x equals b, where b is a positive constant and b is less than 4 but greater than 0. Given that the area of R1 is equal to R2, verify that b satisfies that equation. Okay, so what we've got to do here is we're going to say that R2 is equal to the integral between 0 and b of the equation of the curve. And remember, the equation of the curve is x cubed minus 2x squared minus 8x dx. Okay, now when we integrate that, again, that goes to the same as before, a quarter x to the 4th minus 2/3 x cubed minus 8x squared over 2. But this time our limits are b and 0. So we're going to say that R2 is equal to this. So when we sub this in, this whole thing turns out to be 1/4 b to the 4th minus 2/3 b cubed minus 4b squared minus nothing, nothing, nothing. So basically this expression here is equal to the area R2. Now notice that R2 is below the x-axis, so that means this is going to be negative 20/3. Have to be careful. That's one of the first kind of subtleties about this equation. So we've now got that this is our expression that we've got for integrating between b and 0 and setting it equal to minus 20/3. So at this stage, I think we could times everything by 12. I think that would be kind of sensible in order to do that. So we're going to times everything by 12. So let's just see what that gets us. Okay, so that means that we're going to times that by 4. So we're going to times, just right here, times everything by 12. So that's going to go to minus 80. I want to times this one by 12. That's going to go to 12 over there over 4 will be 3 b to the 4 times this one by 12. That's going to be 24 divided by 3. So that's going to give us 8 minus 8b cubed. And then we're going to times that by 12. So that will be 4 times by 12. So that's going to be like minus 48b squared. And then we've got minus nothing there. Okay. So let's just get all of that over one side. That gives us 3b to the 4th minus 8b cubed minus 48b squared and plus 80 equals 0. So this equation has come from us just integrating between 0 and b and equating it equal to R2. Now it says verify that b satisfies that equation. So in essence now, we've got to show that this equation that we've got here can be rewritten in the format that we've got there in the question. So I think what we should do is we can see that in the question we've got b add 2 all squared outside. So let's see what b add 2 squared is if we expand that. If I expand b add 2 squared, that would be b squared add 4b add 4. So if I divide my expression, my 3b to the 4th minus 8b cubed minus 48b squared add 80 by b squared plus 4b plus 4, then I'm going to hope that what I get is 3b squared minus 20b add 20. Let's hope that that's what we get. So let's do our long division and see what happens. So I first of all compare 3b to the 4th with b squared, and I say to myself, what do I need to do to this to change it into this? The answer is I need to times it by 3b squared. So I write 3b squared there, and then I times everything by 3b squared. So that's going to give me plus 12b cubed. And then I'm going to have times it by everything by 3b squared. I'm going to have plus 12b squared. So I subtract those. That gives me 0. That's going to give me minus 20b cubed. Minus 48. It's going to go to minus 60b squared plus 80. Okay, I repeat the process again. I say now, what do I need to do to this to change it into this? And the answer is that I need to times it by minus 20b. Need to times it by minus 20b. So let's do that now. Going to times that by minus 20b. Okay, and that's going to give me minus 20b cubed. And then I'm going to have minus 80. Minus 80. Now let me just think about this. I can see here that actually I made a cardinal error. I've forgotten to put in there. So let's just amend that now. Remember, we have to fill in the missing terms with a 0b. Let's just amend that before we carry on. There we go, that's better. Plus 0b, like that. So because I noticed that we had 4, 3, 2, but we were missing a term in 0. And remember, when we're doing an algebraic long division, we need to fill in a missing term there. So I put in my 0b there now, so that should be good. Yes, so we're timesing everything by minus 20b. So 4 times by 20, minus 20 is going to be minus 80b squared. Okay, that's fine. And I'm timesing this one by minus 20. So again, it's going to be minus 80b. And take those away from each other. That goes to 0. Minus 60 minus minus 80 is going to go to 20b squared. This is going to go to 0 minus minus is going to go to plus 80b, and then I'm going to have here drop down the 80, so plus 80. Okay, so I now basically say, right, what do I need to do to b squared to change it into 20b squared? And the answer is times it by 20. So I put plus 20 there. So now I get 20b squared. 4 times by 20 is plus 80b. 4 times by 20 is plus 80. Take those away and there's no remainder. So now I've demonstrated that this expression can, in fact, when divided by that, it gives me this as my quotient. So in fact, this can be written as b add 2 squared times by 3b squared minus 20b add 20 as required. Okay, so as required. And that's going to be all of our marks for that part B there, because we verified that B satisfies that equation, because when we integrated between 0 and B, we got this expression, and when we divided it by B add 2 squared, we got that. So indeed, this does satisfy the equation. Okay, that's good. Now, it's this next bit that is so weird. I mean, that bit we've just done was a little bit tricky, I admit, but this next bit is, I don't know, it's kind of like not nice. So it says the roots of the equation 3b squared minus 20b equals 0 are 1.225 and 5.442 to 3 decimal places. The value of b is therefore 1.225 to 3 decimal places. Explain with the aid of a diagram the significance of the root 5.442. Okay, so let's just have a look. Here's our diagram that we're going to use to illustrate what's going on. So here it is. Now, basically, this equation that we've got here has been formed by setting R1 is equal to R2. So basically, this equation is integrating between those two values, and it kind of gives us a resultant of 0. So this equation has been formed by setting the region above the curve equal to the region below the curve. And we find out that it gives us two values that satisfy that condition, where the region above the curve is equal to the region below the curve. We're told that one of them is the value 1.225, and we're told that the other value is like somewhere over here at 5.442. And it says, therefore, B must be the 1.225. So what that means is the solution B is equal to 1.225 is the value that gives us this area being equal to this area. Okay, so that's fine. So that seems to be okay. That's what the significance of B is. It's the value of X that gives us R1 is equal to R2. Now, being as this whole equation has been formed from like setting these areas below the curve and above the curve equal to each other, we've got another solution that's popped up that's 5.442. And what that is if we were to integrate this curve between the 1.225 and 5.442, it's the other value that would give us that we end up with a total area above the curve and below the curve as being 0. So in fact, if we were to integrate from -2 up to 5.442, we would also get a resultant area of 0. Okay, so because this equation's been formed on the premise of setting the area above the curve equals the area below the curve, we've got two values that come out that satisfy that condition. One is 1.225. That's one value where the area above the curve equals the area below the curve. And the other value is 5.442. So that's the significance of the 5.442. It's the other value of X that causes the area above the curve to equal the area below the curve, giving us a resultant of 0. And I think that that's quite an obscure and awkward little thing to understand, but that's the significance of that second solution. It's the value, the second value of X, that causes the area above the total curve to equal the area below the curve. I hope that that makes sense, and I will see you in the next video.